Okay, so today we're going to be looking at, if we're given a set of data, if we're given a story problem, how to take that set of data and fit it into one of these models. Where in the past we've been given a sentence, we've been given a paragraph, and we've been able to create a equation or set up a general equation given just the words. Well, what if we weren't given the words? What if we were just given a set of numbers? How would we be able to tell which graph or which equation we would use in that situation? Well, you might look at all these graphs and think that they all look different, they all look unique in their own way. And it's pretty easy to tell them apart. But when we're dealing with story problems, when we're dealing with real-world data, usually we're not going to have negative values for x and negative values for y. There are some cases where you might, but for the most part we're going to be dealing with all positive numbers, which means that our data is going to be just looking at the first quadrant. So watch what happens if we look at data in just the first quadrant. You can see that for y equals k times x and y equals k times x squared, you can pretty much still tell those two apart. But y equals k divided by x and y equals k divided by x squared still look the same, but yet they're two completely different equations and two different graphs. So we're going to look today at about how to set those two apart, but we're just going to start out in general dealing with any situation. So let's look at our notes. So what this first part is visually showing you is just what I just showed you on that previous screen. Let's look at some examples. It says find a variation equation to describe these data. And by variation equation, what they mean is they mean the specific equation. They don't want the general equation. They don't want one of these. They don't want y equals k times x squared or k divided by x, k divided by x squared, or k times x. That's a general equation. They want a very specific variation equation. In other words, we want to know the value for k here. But in order for us to do that, we need to know, well, what's our general equation? I'm just given a set of points. How can I figure that out? There's actually two ways. One way that gives us a very quick answer, takes a little bit more time, and that's using a calculator. And here's what I mean by being that it gives us our answer quickly, but takes a little bit of time setting it up. We're first going to have to set up a table. So we haven't done that yet this year. Maybe you've done this in the past. What you're going to do is you're going to go down here to the spreadsheet. So it's the middle icon at the very bottom. Before we get overzealous here and start plugging in numbers, we want to label each column. Otherwise, we're not going to be able to make a graph. So I'm going to arrow up. Make sure that you don't type in this gray area here. That's for something else. We want to go all the way to the top where it says A. And we want to label this. We're going to call this the data that we're going to look at. I'll bring that back up again so you can make sure you get that down. You might want to pause the video so you can write down these numbers. But we're going to graph this first table here that's comparing the time in air, which is t in seconds, and the distance fallen, which is d in meters. So we're going to use our two variables there. They give us t for time and d for distance. So that's what I'm going to label my columns, t for time. And you can hit the tab button to go over to the other box. And we're going to use d there for distance. And now we can just arrow down. So I arrow down to this first cell. And I'm going to start by putting in these numbers. So 1, 1.5, 2, 2.5, and 3. Okay, I want to go back up now to the first cell and type in the other numbers, 4.9, 11.0, or you can just type in 11, 19.6, 30.6, and 44.1. Now, a thing to make sure that you know, or that it's very important in order for us to be able to graph, is you want to make sure that when we leave there, that when we get done typing this very last number in, that we don't leave the cursor in that cell. You want to make sure you hit enter or arrow down, because now that value is actually entered into your calculator. You also want to check and make sure that you didn't miss one. So make sure that your numbers line up here, that you don't have the 3 down here with nothing next to it, otherwise you'll also get an error when we try to graph this. And another thing too is to make sure that you don't have a lot of cells open. Sometimes when you have a lot of, not cells, a lot of tabs open. Sometimes if you have a lot of tabs open, when you go to graph it, your calculator is trying to process a lot of information. Sometimes it's a little bit too much and it can't handle it. And I'll show you how to clear all that out here in a minute. Okay, so now let's create our table, or let's create our graph now that we have our table. So what we do is we go to the home button, and we're not going to go to this graph. Okay, this graph here is when we know the equation that we can type in to graph the line. That's where we go. If we're given data and we want to create a graph, we go over here to what looks like a bar graph. And basically, your screen might look completely different. What it does is this screen it takes and spews all the data that you have in any table. So if I had more than one table open, all the numbers it would just throw out down there on the screen. But we want to take and organize this data, these points, into a graph. And so you could either use your arrow to scroll down to the bottom here. That could be kind of a pain. A quick way to do it is you just hit the tab button. Now we want to select what axis we want here on the bottom, D or T. It's important that we put our independent variable on the bottom. Our independent variable in this case is going to be the time in seconds. But I want to have that's just an x-axis. I want to have a y-axis as well, so I'm going to hit the tab button again. That goes over to my y-axis. And now I can select D for the distance fallen there on the y-axis. Now this, at first glance, might look like these fall in a straight line, but if you look carefully, you can see that it's kind of a curved line there. It's not perfectly straight. If it was perfectly straight, it'd be going across like this, maybe going down like this. So it's not perfectly straight. It is a curved line, which implies that it's in the form of a parabola. Okay, meaning that if I were to continue this out, it would be looking like this. It would be in the form of a parabola. So that means this graph here would be in the form y equals k times x squared. Let's go back to our graph, or our notes. But remember, we're not using y and x, we're using t and d. But you want to make sure that you set this up correctly. So we know that it's going to be in this form. But again, instead of y and x, we're going to use d and t. So our general form would be d equals k times t squared. But remember, they're not asking for a general equation, they're asking for a specific equation here. So our next step is to find k. Remember in those 4 steps that we talked about, and if you've forgotten, you want to go back and watch the video for lesson 2.1. So that way you can remember what those 4 steps are, or look back in your notes. But the first step is to come up with a general equation. Our second step to find k is we need to have 2 values for d and t. Now I actually have I have 5 values here. I could use any pair of numbers here and put these in to figure out what k is. So it doesn't matter which pair of numbers we use. So if it doesn't matter, I like to pick the ones that looks like would be the easiest, and it looks like 1 and 4.9 would be the easiest here. So I'm going to put 4.9 in for my distance and put 1 in for my time. Well, 1 squared is obviously 1 times k is just k. So that tells me the value for k is 4.9. And again, that's not my answer. That's not what they're asking for. They're asking us to find a variation equation. So the variation equation in here would be d equals 4.9 times t squared. Now, you don't want to just assume that you have the right answer, because what if this was supposed to be a straight line? What if there wasn't supposed to be an exponent here? This equation that we have here should give us approximately all of these answers. So if on your calculator you took 4.9 times 2 squared, you should get something close to 19.6. So let's check that. So if I took 4.9 times 2 squared, or 4, I should get something close to 19.6, which I do. And you should probably try that for more than one, just to make sure, but we can be pretty confident now that this would be the variation equation that describes the data. So now we can use this variation equation. So sometimes there'll be a follow-up question like they did here. It says use your equation to predict how far an object would fall after 6.5 seconds. Our table doesn't go that far, but I have an equation that would allow us to make the prediction. So I would take 4.9 times 6.5 squared. And again, you don't want to make a prediction until you've verified that that equation that you're using is going to give you an accurate answer. So again, make sure that you always check before moving on or before making any predictions. So now if I take 4.9 times 6.5 squared, if you do that on your calculator, you end up getting 207.025 as your answer, and this would be our distance, so it's going to be in meters. Let's look at the next one. Now with this next one, I'm going to show you how to do it without your graphing calculator, and we'll verify it maybe with our graphing calculator. But to do this, what we're going to do is we're going to start out by looking at one of our values for x. I'm going to start out with the 1. And actually, you know what, before we even do that, we want to check to see, is this an example of direct variation or inverse variation? Remember, to see if it's direct variation, we ask ourselves, well, as one variable increase, does the other variable also increase? If so, it's direct variation. If one variable increases and the other one decreases, it's going to be inverse variation. So as you look at this, the x is increasing, going from 1 to 3. The y is also increasing, going from 3.2 to 28.8. So this is an example of direct variation. So my next step is I say what I did already is I pick this 1, and I say, well, 1 times 2 is 2. So remember from lesson 2.3, if I had direct variation, I said whatever happens to x, the same thing would happen to y to the nth power. Well, if x gets multiplied by 2, that means y is going to be multiplied by 2 to some exponent. We want to figure out whether that exponent's 1. We want to figure out whether the exponent's 2. I suppose it could be 3, but for what we're going to be using for the purposes of these problems, it would be either having an exponent of 1 or an exponent of 2. Well, 3.2 times 2 to the first power is just going to be 6.4, not 12.8. 3.2 times 2 squared, well, 2 squared is 4. 3.2 times 2 squared gives us 12.8. So here's what that tells me. That tells me that this is in the form of y equals k times x squared. Because of this square, I know that the power in my equation is going to be the second power. As a result, now I don't have to create the table. That's what I meant earlier about the fact that, yeah, the table is nice because it gives us a graph, and we can look directly at the graph to see what form it's in. But that really only helps us if it's k times x, or if it's a straight line or a parabola. But if it's a hyperbola or an inverse square curve where quadrant 1 is going to look the same for both of those, using the graph is not going to be helpful. Now you've just used up all this time setting up a table and creating a graph. And that's why personally I like doing it this method. It gets you directly to your answer very quickly. It just takes a little bit more math. So now I know it's in this form, y equals k times x squared. So now I can jump into, right away, finding out what k is. To figure out what k is, I can use any pair of numbers here. I'm going to use one different from the one in the 3.2, just so you can see how other numbers would work. Let's use the 2 and the 12.8. So if I put 12.8 in for y, make sure you put these in the right spot, I'm going to put 2 in for x. It would be 2 squared, or 4. So I divide both sides by 4, or 2 squared. And that's going to give me a value of k, which is 3.2. And again, we're not asked to find k, we're asked to find a variation equation. So make sure that you don't just stop here, otherwise you're going to lose points. So our actual problem is y equals 3.2 times x squared. What that means is that this equation is what we'd use to get all these points. So you should make sure that you verify it. Okay, so this video that I use, or this program I use, limits me to only 15 minutes at a time. So I'm going to actually have to stop this video. But watch the next video to see how to do problems involving inverse variation. So we'll be looking at that in a minute.